All right, here's your review for your radicals and rationals. So let's go ahead and let's get started with the first thing. It says to write each of the following in simplified radical form. So I'm going to start right here with this one. So remember, whenever you're trying to simplify, you want to look for, you can factor out any perfect squares. And in this case, remember, it is a square root with your index of 2. So what I like to do is I like to factor it with the perfect square. So I take the square root of 9 times the square root of 20. Now this is going to give you 3 because square root of 9 is 3. But square root of 20 isn't a perfect square, so we have to continue to factor to root 4, which is 2, and then root 5. Well, root 5 can't simplify to a perfect square, so then you just multiply your other 2, and then you get 6 root 5. For this one, when you have variables within it, now remember your index is 2 if it's not written, there's a couple ways to do it. You can either take the square root of 16, which is 4, and then remember, for every 2 w's, you can pull those out, or you can write it as a fraction. So this would be 4 over 2, which simplifies to 2. And then this would be your final answer. Another way to see it if you get stuck or you get confused is factor it all out. And every time you have 2, a group of 2, because your index is 2, you can take that outside of the radical. So here, I've got a 2 that can go outside the radical. I've got 2 w's that can go outside, and another 2 w's that can go outside. So then, once you get everything outside the radical, multiply it together so you can get your final answer of that. Oops, I think I forgot to write. I wrote 2, not 4. My bad. So 4. There you go, and that's your final. All right, and then let's come over here. Now, if you were to have a fraction that has a square root, if it doesn't simplify easily within the under the root, you can break it up. And then once you break up the root, then you can go ahead and simplify, and this is your final answer. Now, for this, same thing as before, break down into a perfect square. And once you got your perfect square that goes outside the radical, whatever is left over stays in the radical. And then for here, you could either write that as a fraction and simplify, but every time you have a group of 2, kick it outside the radical. So same thing here, and anything that's left over goes in the radical. So when you finish, that's why I've got a leftover a here, leftover a here. I've got a root 3 here, a root 3 here, and then everything else that's able to group by the index goes outside. So this is your final answer. Now, whenever we get negatives, if it's an even root, you're going to want to factor out the negative because you can't have a negative under the radical, so you have to. It's an imaginary number, so you have to factor that out, and then you go ahead and just factor out the rest. Well, I could do, if this were square root, I would just say it's 16, but it's not. It's the 4th root, so check your index. So I'm going to try to break it into 4 of the same factors, and that's why I continue to break down 16 times 16 to 4 times 4 times 4 times 4. So then you take a group of 4, kick it outside the radical, and then your I is outside the radical, and that's your final answer. All right, let's come over here to 7. Now, before we separated, when we were up here, we separated. But now you can actually combine them if it actually ends up giving you a perfect square. So what I did here is I just combined both the radicals, and then I simplified 300 over 3, which gives you 100, and then the square root of 100 is 10. Now, in this case, since it's the 3rd root, you want 3 of the same factor. So when you're factoring it out, you're looking for 3 of the same. And then once you get that, you put it outside the radical. And then here, I don't have 3 of the same, so all this is left over, which stays in the radical. And again, it's an even root, so you're going to factor out that negative to make it I. And then once you've got that, then I like to factor to your perfect roots and then whatever's left over. So it's 3i is outside, and then your leftover would be root 6. All right, now remember, you can't have a square root in the denominator, so you have to rationalize it. And when you rationalize, you take whatever this is, you're going to multiply the numerator and the denominator by it. So when you go ahead and you get this, you're going to get 5 root 2. And then remember, square root of 2 times square root of 2 is square root of 4, and the square root of 4 is 2. So that's where we got that 2 from. All right, and then your fraction doesn't simplify any more than that. All right, let's look here. We want to write as simplified rational exponents. So remember, your index is the denominator when you're writing exponents. So here in this case, it's not written, but I did write in a 2. And then if you look, y does not have an exponent. So if no exponent's written, I always put in a 1 so I don't forget what's there. All right, so you're going to go ahead and you're going to write the base, and you have your numerator, which is 3, and your denominator, which is the index. Same thing here with your x's and with your y. Once you do that, 3 halves you can't simplify anymore, but if you notice, 2 halves can simplify to 1. 1 half stays the same. So now, simplify that, but we don't write the 1 in at the end, but we know it's there. And then this is your answer. All right, for this one, rewrite any number. So in this case, since we have 16, I'm going to write that into whatever factor works best. So in this case, a 2 is going to work best for us. Oops, where did we go? Here we are. So this 16, I'm going to break it down into 2 to the 4th power. Now that I've got that, remember this is your denominator, and I write your numerator here. And then I'm going to continue the same thing here, and then we can't break it down anymore, so that's as low as we go. All right, now this one, there's a couple different ways you can do it. So remember, there's different ways to simplify. As long as your final answer is the same, then you're good. So you could take 64 and make it 4 root 3, which works because you get 3/3, which makes 1. And then you would get 6/3, which make 2. And you get 12/3, which make 4. And then this is your answer. Or let's say you broke it all the way down and you did 2 to the 6th power. That's fine, because you're going to get 6/3, which simplifies to 2. And then these are going to be the same thing as before. And then you'll be left here with 2 squared. Well, 2 squared is 4 anyway. So we got the same answer. It doesn't matter which way you do it, but your final answer should still be the same. All right. Now let's come down here. A lot of writing on here. Write as a single radical. So remember, in order to do this, you have to have a common denominator or a common index. So right now, you've got 2, 3, and 5. So we need to make that 30 is a common denominator for 2, 3, and 5, and then just make an equivalent fraction. So 1/2 is the same as 15/30, 2/3 the same as 2/30, and then don't forget this negative here, that's very important, and that's going to be 6/30. Now, whenever you have a negative exponent, you have to flip it to the denominator if it's in the numerator to make the exponent positive, or vice versa. If it's in the denominator, flip it up to the numerator, and it changes the sign of your exponent only. So that's what we did here, is we left the positives in the numerator, and then we took this guy and we flipped it. So if this was -6, we flipped this down to the bottom to make it a +6. And then this is your final answer, and it's all with an index of 30, so it's to the 30th root. All right. Now you're going to solve problems. So remember, use the inverse operation. So first, move the 7. You want to get the radical all by itself. Then once you get the radical by itself, you're going to do the root to the opposite is to square it. So you square both sides and then solve for x, and then x equals 6. So same thing here, but first what you need to do is move the 20, and you want to get this part by itself. Don't forget to divide both sides by 5 after. A lot of people during the test wanted to divide by 5 first. You can't do that. You want to get this by itself first. Then remember, inverse, or the reciprocal. So if you have 2/3, you need to multiply by 3/2. And you can enter that into your calculator. Just remember, it would be 4. I'll write this with my pen. And then I like to put it in parentheses. But remember, this is your exponent. So 4, and then put it in the parentheses like that. So you could do either way. All right. And then for 17, this is kind of a tricky one because you're going to go ahead, you're going to add the x to both sides. And then you notice you're going to get 2x plus 7 to the 1/2 power equals x plus 1. Well, to undo this 2, or 1/2, we have to multiply by 2. Now, what's very important here is this cancels each other out, so you have an exponent of 1. But look here. This is x plus 1 squared. That really means x plus 1 times x plus 1. So you have to distribute all of it, and then you're going to get this. So don't just do x squared plus 1, because that's not what you're going to get. And then you're going to move these over. And then that's where we got 0 equals x squared minus 6. And I added 6 to both sides. And then take the square root of both sides. Now you're going to get plus or minus root 6 as your answer. Now, if you get 2 answers, you have to check for extraneous roots. Now, I'm not going to do that just for time meaning, but what you're going to do is wherever you see x, you're going to plug in or substitute in positive root 6. And then you're going to substitute, and if it works, if you get a true statement or if it makes sense when you're finished, you solve it, you're good. Then I'm going to try negative into here. And when you solve this, the negative root 6 doesn't work. So your only answer would be a positive root 6. So if you get 2 answers, check to make sure you don't have any extraneous roots. All right. And then for this one, it says it's your inverse variation. So indirectly, so you got inversely, when it's measured 120, pressure 4 inches, what would be the equation? So remember, if it's directly, you're going to multiply. So it would be like k times x or whatever it is. And if it's indirectly, you're going to divide. So it would be like k divided by x or whatever it is. So the important thing is find k first. Once we know what the constant of proportionality is, then you can go ahead and solve everything else. So it says here, energy relates inversely, so you're dividing, to the amount of pressure applied. So it's divided by pressure. So that means that k is going to go in the numerator. And then just substituting your values that it gives here, solve for k. And then you'll get k equals 480. So all it's asking is just the equation. So once you get that, just substitute it into here. And that's all I did. All right, so for this one, it says the volume of V of the gas is a constant which varies inversely, so that means you're dividing, with the pressure P, so you're dividing by P. When the volume, and so this second part is just what you do next. So this first part is telling you what to do, or sorry, so set it up, and then now the volume is 100. The pressure is 25 pounds. And now that we've got this, now we can solve for k. So find k first. Now once you find k, we can put it back into our original equation. And then now we can start substituting in the values for pounds. And then you'll see when you substituted it in that 20 will go ahead. So you're looking for 125. So you're substituting that in to where volume is. Solve for P. And P is 20, which is the correct answer. All right, number 20, inverse means you're dividing. So all you got to do is take this divided by that. So we're just going to check to see basically what your rate is or your constant of proportionality. So constant of proportionality is what we're looking for. So when you go ahead, do 48, you're going to multiply both sides by 4. and then k equals 192. And you're going to continue the pattern for here, and you'll see it also equals 192. Continue the pattern for here, you see 192. So you know k equals 192. So now we're going to substitute this back in and figure out which one matches that equation. Now, domain and range. Remember, domain are your x values, range are your y values of your square root. So we've got a graph, and so here, remember, this is x minus h, and I like to keep h in parentheses, plus k, because you're going to do the opposite sign of whatever it says. So your anchor point is hk, or like the vertex of your square root graph, but that's right here. So in that case, your anchor point is for -1, because this is a positive, so you're positive you get that by doing two negatives. And then when you're finding the other points, this is your first point that we found. I like to try to make a perfect square under the radical. So if I were to substitute in -3 here, you're going to get square root of 1 minus 1. Well, that's 1 minus 1, which gives you 0. And then now, if I were to plug in 0, you're going to get root 4 minus 1, so that's 2 minus 1, which equals 1. And then you plot your points. It should look like half a parabola. And then the domain are your x values. So you can see it written two ways. It can say x is going to be greater than or equal to -4. So if you're going here, it's your x values. And y is greater than or equal to 1. Now remember, it doesn't go straight up like this, but it does continue on where your y's are going to increase every time. So you'll see it written like this, or you may see it written like this. And remember, if it's the point included on it, you do it like this. If it's like infinity, you'll put a parenthesis. So either of these would be things you could potentially see. All right. And then that is your radical and rationals final exam review.